Well, welcome back to our course on system engineering. And in this lecture, we're going to be talking about enterprise system engineering. And just to give some context, we're now in the last of the sections that we're going to be covering from our textbook. And this is where we'll get a chance to get exposed to systems domains. And the first thing that we'll be talking about is enterprise systems engineering. So let's go in and get started into the material. So what is enterprise system engineering? So it is a multidisciplinary approach combining systems engineering and strategic management to address methods and approaches for aligning system architectures with enterprise business rules and the underlying IT architecture, development and implementation consistent with enterprise strategic objectives and the total enterprise system and capabilities with diverse complex subsystems. The system engineering lifecycle can be used as a framework for linking outcome-based engineering analysis and decision-making with enterprise strategic objectives, addressing methods and tools for managing complexity, determining measures of effectiveness, and assessing return on investment from an engineering perspective. Enterprises are complex and have a multiplicity of technical and business components involved in delivering enterprise capability, as well as methods for modeling and analyzing their interdependence. Business and technical interdependencies exist among the infrastructure, computing, application, services, and other user environments. Enterprise system engineering is the approach, principles, and practices having to do with the design, analysis, and operation of an enterprise, an entity, a cooperative people who have a defined social or government purpose. As a system or family of systems, it is best considered holistically in traditional system engineering fashion. However, this approach incorporates people as a component of the system, viewed as an agent of change and continual design evolution. Hence, applying the system engineering approach is important in understanding changing requirements during the interaction of many social groups in the enterprise during development and use of the product. Enterprise system engineering is also considered as a specialty of system engineering that focuses on the enterprise that will contain more than just the system, but also the people, processes, and environment that the system will operate in. These enterprises are generally larger scale than having a single system, often involve complex systems that cross more than the system boundary and must continually adapt to the operational environment to include emergency threats, technology improvements, and a change of systems, organizations, and stakeholders involved in the enterprise objectives. The enterprise may also wish to continually evolve itself in order to improve the standing in their respective domain or market, either through integrating or acquiring additional capabilities, improving shared processes, sharing of information to make more efficient decisions, and systems development, and accommodating evolving user demands of the system and enterprise services. Additionally, enterprise system engineering motivations can include the enterprise modifying their vision, goals, and governance of their current position, as well as adjusting to the political and economic situations. Traditional systems engineering that focus on single systems may not be adequate to address these enterprise challenges due to the lack of additional factors such as people, processes, and technology that would address these issues. Enterprises may also adjust to the external environment with their loss in market share due to competitors' gains, their own failure to meet their stated goals, or an identification to improve their position in the market. These three insertion points can help enterprises shape their future directly, their future direction by adjusting their enterprise system engineering approach towards the threats, environments, and their own goals. So let's talk about a couple of things here. The definitions of system engineering. And we'll also have what I'm showing here on the slide to give you a top level perspective of this. So there are several definitions of enterprise system engineering, most of which identify the enterprise as a collection of systems that have people, processes, and technology that interact with the entire environment to achieve their objectives. Enterprise system engineering also work with complex adaptive systems that will exhibit emergent behavior or environmental dependencies, in which case we cannot simply predict a system performance just through their individual characteristics, but rather the collection of multiple systems may exhibit an unpredictable behavior as a system will work together to achieve their objectives. Systems within the enterprise system engineering environment will interact with each other, and based on the interaction pattern and response to the environment may produce unpredictable capabilities and behaviors as the enterprise matures in capability as well as the objective achievement. There may be a certain decision milestone in order to change the system, people, and processes or technology that contribute within the enterprise in which in which to further the enterprise goals. The selection may require some of these elements be removed and or other elements be added to the enterprise, mainly in response to the enterprise goals, external environments, threat or competition, or changing market and user needs. One of the references from the textbook, Stevens identifies megasystems that are large-scale, potentially complex systems that cross boundaries to achieve a shared objective, which can be drawn to further developing the enterprise definition. These requirements for the megasystems are instead a collection of vision statements and broad architectures rather than a fixed set of artifacts. The mega system performance depends on the interaction of the components that make up the system, which may not be initially known or envisioned when the development process starts. As there may be many components within the mega system, some of the traditional help program boundaries may need to be crossed with these components in order to achieve the objective, which again may not be known initially or planned when under development. So the enterprise system engineering stakeholders may take the form of customers, suppliers, partners, employers, stakeholders, or the community at large. I'll get to this chart in a minute, this table in a minute, but just trying to give you a comparison of the looking at traditional system engineering versus enterprise system engineering. There may be different system goals and pressures to perform based on different stakeholders' needs at different times in the system. Lifecycle operations, as imagined with some larger systems in the environment changing due to user demand. The enterprise may react differently to various stakeholders based on the environment, their competitors, and user demands. The need for enterprise system engineering agility to react quickly to the various stakeholders bases can have different implications on the composition of the enterprise, forcing changes in the system, organization, and management, which we mentioned earlier. So this table provides a comparison of traditional system engineering and enterprise system engineering attributes that can provide some insight into the differences in which the systems engineer should approach and analyze the enterprise. Here we're seeing a figure showing enterprise system engineering and having a context diagram. And so this is a simplified context diagram of an enterprise system engineering engineer should consider in order to address all of the complexities and interdependencies. Some of the questions listed below that we'll talk about here, listed in the textbook, can help expand the enterprise system engineering context diagram in order to better define the enterprise composition and objectives. One, are the most critical stakeholders. What are the most critical stakeholders of the enterprise? If one were removed or degraded, would the enterprise still be able to function satisfactorily? What would be the end result look like? Would that be acceptable to the rest of the enterprise stakeholders? Two, what are the most critical interfaces of the enterprise? If these interfaces were altered, how would that affect the rest of the enterprise? How much of the enterprise would be directly and or indirectly affected with the modification of these interfaces? What would be what would the enterprise do in order to compensate for these changes? Number three, what are the threats to the enterprise? Will these threats affect single portions of the enterprise or multiple areas with the same threat? Are there ways to prevent or harden the enterprise to mitigate these threats? What would be the impact of the rest of the enterprise if the portions were protected? Would that cause the threats to dissipate, or would there be other vulnerable areas in the enterprise? And finally, four, what is the quote currency of the enterprise? What inputs are required for portions of the enterprise to operate properly? Are these inputs compatible with the other portions of the enterprise, or do they need to be modified to be interoperable? If given different inputs, would the enterprise still function? How would the behavior and performance change under these new inputs? Okay, we have a couple other things that we'll cover here from the textbooks. And first of all, we'll talk about the processes and components of enterprise system engineering. Much study has been conducted on the processes and principles that can be used to describe enterprise behavior and activity. We're showing three here, and we'll talk about them shortly, are some generalized processes and principles, but as with any enterprise, these would be highly tailorable to the domain environment, threats, and objectives. So first, the enterprise processes. The textbook gives a reference, DeRosa, Rabovic, and Swartz developed five key enterprise system engineering processes that describe the activities that an enterprise would undertake while in development and execution towards their independent objectives. These five steps are technology development, capability-based engineering, analysis, enterprise architecture, strategic technical planning, and enterprise assessment and analysis. So we'll talk about these briefly below. For technology development, it looks at the trend in the current marketplace as well as the researching in order to identify the current capabilities as well as future opportunities. These new capabilities can be assessed in their ability to operate with existing enterprise capabilities and technologies in order to determine the best mix of the enterprise capabilities for the current and future situation. For capabilities-based engineering analysis, it looks at the capabilities of the enterprise as a holistic view and not focusing on a single system. From here, the stakeholders can determine their existing capabilities and look to the future for their desired capabilities and how portions of the enterprise need to be matured and evolved to achieve their goals. This may require improvements to existing parts of the enterprise, removal of other parts, or forming new partnerships in order to achieve the capability. This planning and goal setting is typically done via an integrated and time-phased roadmap to show the evolution of the enterprise. Another reference from the textbook, Sitton and Reich, emphasize focusing on cross-enterprise operational processes as they argue that this may allow the evaluation requirements conflicts between systems, allowing compromises to emerge. Then for enterprise architecture, it describes the components of the enterprise as well as their roles and relationships with internal and external parts of the enterprise. These architectures may need an interdisciplinary perspective in order to properly capture the aspects of the enterprise to include uncertainties, dynamics, and investment. These architectural models will likely undergo a continual modification to reflect change in the architecture or operational environment. Sitton and Reich, again, studies and enterprise architecture lead to the conclusions that because the system and networks in the enterprise already exist, their developments are unsynchronized with each other, leading to a dynamic architecture. They conclude that it will be difficult to plan enterprise architectures like a single system, as there is less control over the individual systems and their capabilities. They suggest a new methodology towards management of the unsynchronized elements within the enterprise. We have strategic technical planning, which helps to plan the needed initiatives in order to reach the desired enterprise end state. The planning starts by baselining the enterprise to account for the current state, then modifying the baseline to arrive at the grand vision, and finally simplifying the steps to create a shared image of the enterprise. So it is easily understood, believed, and accepted by stakeholders in the enterprise. We also have enterprise analysis and assessment, which helps to select the option that the enterprise can take when approaching the grand vision. Use of modeling and simulation can assist the stakeholders in evaluating the enterprise behavior and various outcomes as multiple permutations of the components of the enterprise are modified. The use of what-if scenarios is relied upon to explore the multidimensional trait space of the enterprise in order to determine what parts of the enterprise need to be added, modified, or removed. Another reference from the textbook, Martin studied the enterprise system engineering processes and argued that the use of business school portfolio analysis can help the enterprise to determine the optimal mix of assets and capabilities. This portfolio approach can help to combine different platforms, facilities, and policies to achieve the enterprise objective. Using resource allocation principles can also help determine the distribution of resources such as systems, people, facilities, and funding to help address shortfalls in areas within the enterprise that require additional attention. That's as a long review of the engineering processes. Let's now get into the engineering principles. Another reference here, Nightingale lists 7 principles of enterprise thinking that are complementary to the 5 enterprise system engineering processes that we talked about under engineering processes. The first principle is to adopt a holistic approach to enterprise transformation so as to consider the various lifecycle processes, leadership processes, and enabling processes that may suboptimize systems to ensure that the enterprise will improve. The second principle is to identify relevant stakeholders and understand what they value from the enterprise so as to focus on the desired capabilities of the enterprise. The third principle focuses on the enterprise effectiveness over its efficiency in order to first advance the objectives. The fourth principle focuses on the internal and external enterprise interdependencies in order to determine which controls and processes are under control and which are dependent on external entities. The fifth principle ensures stability and flow within and across the enterprise, which can help formulate a baseline of the current state of the enterprise and then measure where improvements could be made. The sixth principle encourages leadership to support and drive enterprise behaviors in order to attain buy-in from the enterprise and to seek improvements of the micro level to help better the enterprise. And the last principle is to emphasize organizational learning in order to engage the enterprise at all levels in order to continually experiment and gain deeper insights into encouraging transformation of the enterprise. Then we have enterprise management. The final thing we'll talk about for this first other topic, the modern enterprise, whether commercial or government, may have developed a strategic plan with organizational leadership focused on specific outcomes and directions moving forward. The enterprise system engineering context for successful system development expects the system engineer project leadership to be aligned and contributing to the goals of the organization. And so to be connected and fully utilize the enterprise net-centric infrastructure to help grow and transform the employees for future enterprise endeavors, provide early identification of resources needed for the project and benefit for the enterprise, share system engineering and project knowledge gained to enhance future successes, seek to develop and share processes, software, and capabilities across the enterprise, and finally, to encourage high team performance and stakeholder appreciation. Next, we'll talk about these two other topics. First, the enterprise system engineering application to domains. Enterprise system engineering will span multiple domains and may require a different approach to successfully achieve the enterprise objective. Listed are some enterprise examples on where enterprise system engineering principles could be applied. Some representative industries and elements could apply to the enterprise system engineering principles. The aerospace industry contains many multiple stakeholders. In order to reduce cost and cycle time, the health care industry looks at the interdependencies between other hospital units in order to address overcrowding in the emergency departments. The automotive industry exchanges information across functional units while developing cars to reduce their development time. The US government looks to share an enterprise strategic vision that prioritizes selected projects in order to improve mission effectiveness. Another reference from the textbook, Pencock and Rose look at the challenges of modeling enterprise system engineering and identify some example issues that require analysis and further insight into the details of each system and process in order to estimate the enterprise behavior and end state when the issue is addressed. The first example is addressing counterfeit parts in the defense industry, requiring the modeling of a supply chain, supplier economics and values, and the system assembly networks and controls. The second example is congested pricing of employing selected transportation technologies, where the transportation ecosystem networks, flows, and driver behaviors and decisions will assist in evaluating the transportation enterprise performance. Third example is in urban resilience and the evolution of the urban ecosystem while accounting for the networks and flows of energy, water, and people, as well as accounting for residents' perceptions, expectations, and decisions. These exemplars can be analyzed using enterprise system engineering processes and principles to set up the enterprise objectives and to understand and guide the development of the elements, relationships, and resources to achieve the objectives. So as shown in these examples, the applicability of enterprise system engineering processes and principles may need to become tailored to specific domains and the challenges that it presents. There may be some utility in deriving lessons learned and best practices from a previous enterprise system engineering application and transplant that into a different domain, but caution must be made to ensure that the approach takes into consideration the sensitivities and nuances that each domain must require. Finally, we'll talk about challenges to enterprise systems engineering. The enterprise system engineer will undoubtedly encourage challenges to the enterprise as it moves from one phase to another in search of reaching its objectives. Some setbacks may be out of the control, such as emergent threats, competition, or changing user needs. Other elements may be in its control, such as the identification of deficient, inferior, or outdated elements of the enterprise that is dragging down the enterprise performance. A reference from the textbook again, Rose lists several strategic challenges that enterprises may encounter: growth, value, focus, change, future, knowledge, and time. Other challenges may be that the enterprise may intend to set objectives, but the different elements within the enterprise may not be optimized or configured to achieve these objectives due to the external competitors, the external environment, external user demands and needs, or lack of synergistic effects within the enterprise. Some of the elements inside the enterprise may not be controlled or influenced. There may be some second order effects that prevent the attaining of these objectives. System engineering development in the enterprise context can bring about unforeseen risk and opportunities of the scales of change across the enterprise, and the various new systems can create conflicts that must be resolved by enhanced communication and boundary resolution. The enterprise hierarchies can be addressed by accepting some risk to accommodate new opportunities and obtain improved system performance. Opportunities may develop when the enterprise system engineer anticipates social or military needs and facilitates developing an enterprise where enterprise capabilities exist and where system products could be produced by the organization. Systems thinking and holistic enterprise perspectives are the domain of the system engineer, where significant changes can be taken to an advantage. The enterprise system engineering engineer will have challenges to recognize how the elements of the enterprise work together, as well as with the external forces, and understanding what may have the largest impact on the enterprise to help attain the system objectives. Sometimes this may not occur in the short term, but needing a long-term approach toward enterprise operations, allowing the competition and market forces help drive it towards the desired objectives. Other challenges that enterprise system engineering engineers may have to encounter are the external forces that the enterprise may not have any control over. One significant element may be the shifting user demands or how the enterprise capability is envisioned to be used, which may be different than the original design and development approach. Through understanding of the technologies as well as anticipating user demands, can the enterprise system engineering engineer hope to guide the direction of the enterprise to account for the projected future demands and position. As the enterprise works with a longer time frame, the envisioned trajectory of the enterprise position may be more difficult to predict successfully without course corrections. Okay, well, we'll just finish up with a short summary review. We've talked about two things in this chapter: enterprise system engineering. Enterprise system engineering can be described as the people, processes, and technology that interact with the environment to achieve the enterprise objectives. As the enterprise matures, components of the enterprise may be subject to additional modifications or removal based on the external influences and other influences. Then, in terms of processes and components of enterprise system engineering, the enterprise system engineering processes can include technology development, capability-based engineering analysis, enterprise architecture, strategic technical planning, and enterprise assessment and analysis. Okay, well, thank you very much. That'll end it for this lecture.